The next topic that we're gonna study is gonna be other applications of derivatives of the functions. This topic will be kind of important in order to study calculus. The curve sketching is gonna be the thing that is gonna be our objective. However, before we be able to do the curve sketching, we're gonna have to pass many topics as you can see here. I'm gonna first mention the overall first. The overall topic that's gonna be studied in this lecture is gonna be the increasing and decreasing maximum and minimum value and extreme value. So this thing will be just the easy stuff. Okay, so I would mention that this one seems easy. The next one will be about the optimization problem. The optimization problem turned out to be word problem that we're gonna apply the thing that we study on the increasing, decreasing, and minimum, maximum, and the extreme value for the word problem. So this one will be the word problems. And you have concavity, vertical and horizontal asymptote, and the shape of the graph. These four, these three guys turn out to be about preparation for curve sketching. Okay, so this one will be like a three objective for this one. It should be about 4 video from this guy. Okay, so we're gonna study this one like a little bit until we obtain everything that make us ready to uh, sketch the curve. The first one that we're gonna study is gonna be about increasing and decreasing function. As you can see from the graph here that you're gonna have the interval. So you're gonna have from A to B, from point A to point B, from point A to point B, from point B to point C, the function look different in shape. And you have point C to point D. From From point A to point B, you see that the graph of the function is increasing. What does it mean to be increasing? It means that you have whenever x1 less than x2, okay, so whenever x1 less than x2, you have x1 less than fx2. So the function will be look like this one will be increased when x1 increases to x2. So this one is the definition for increasing. Another one is called decreasing. Okay, it is called decreasing if you have fx1 turn out to be more than fx2 whenever x1 less than x2. So you see this one is the case where we have b to c. How would we determine increasing and decreasing? Okay, so how could we determine whenever we have increasing or decreasing function without using the graph? The thing that you can see here also, if you draw a tangent line to the curve, okay, so if you draw a tangent line to the curve, okay, let me draw a tangent line to this curve. You're gonna see that the tangent line here has slope positive. Okay, so this one has slope positive. This one positive slope. Okay, so this one has positive slope. And you also see that from C to D, if you draw a tangent line, this guy also has positive slope. okay? And if you draw a slope or draw a tangent line from B to C, so the thing that you may have is turned out to be like this. This guy turned out to be negative slope. Okay, so this one is negative slope. So you see that we be able to like be able to determine increasing and decreasing from the slope. So it's gonna be that you have increasing. Okay, so you have increasing if and only if you get positive slope of tangent line. Tangent line has positive slope. Let me write this one. Increasing if and only if tangent line has positive slope. Okay, and decreasing if and only if the tangent line has negative slope. Okay, so the side of the slope turn out to be the key thing in order to determine decreasing and increasing. So we will have two conclusion. So it's gonna be the derivative of f is positive, then you have the increasing function. And if the derivative of f is negative, which is you have the slope is negative, so it's gonna turn out to be decreasing. Okay, so this one we can use derivative in order to determine decreasing and increasing for us. So for fx equal to x squared, so when you have fx equal to x squared, if you graph this one, you're gonna obtain a parabola open upward. So you get a parabola open upward, and you see from the graph that you have decreasing down here. Okay, so you have decreasing from x negative and you have increasing when x positive. Okay, so this one is the graph for y equal to x squared. Okay, so you see that you have decreasing in this interval and you have increasing in this interval. If you want to use derivative, you just find the first derivative. You have f prime x equal to 2x. Okay, so you have f prime x equal to 2x and you're gonna solve for 2x positive and 2x negative. So when you have 2x positive, it means that you have x positive. So the graph is increasing. Okay, so it's increasing. Okay, and you have x negative. you have decreasing in this case. Creasing. Okay, so you have decreasing and increasing. So here, the thing that we have here turned out to be, in order to determine positive or negative side, we're gonna have some like a boundary. So let me draw a real number line. Okay, so you have the zero in the middle, and you see that you're gonna have the positive when x more than 0. So this one is positive for psi of f prime, and you have psi of f prime to be negative after this guy. So this guy is decreasing and this guy is increasing. Okay, and this one, you see that we have the midpoint. In this case, this guy turned out to be the point where you have derivative equal to 0. Okay, so this one will be the point where you are having derivative equal to 0. Okay, so you are in the yellow interval and you are in the blue interval. Okay, so in this case, the important point that used to separate increasing and the increasing and the decreasing interval turn out to be the point where you have derivative equal to 0. So this is the reason why we will solve for derivative equal to 0, and you're gonna get x equal to 0. And this guy will have a special name. This guy is called the critical number. Okay, so this guy is called a critical number in this case. Okay, so this one will be the thing that we gonna do next. It's gonna be we gonna find the derivative of the function, and before we distinguish about the sign of derivative, we're gonna find the critical number first. The critical number will help us to know where we're gonna change the sign. However, in this case, we may have to test the sign in this interval. This one, if you recall from your high school, is gonna be calling the sign testing that you use for solving inequality. The next one, you have fx equal to negative x plus 2 to the 2/3. So in this case, you're going to differentiate this one first. So you have f prime x let me separate this one a little bit. So you get f prime x equal to negative 2/3 x plus 2 to the negative 1/3. Okay, and this guy equal to negative 2/3. Okay, and you have 1 over x plus 2 to the negative 1/3. Okay, so you see for this one, it's gonna be f prime positive. So f prime x positive. So we're gonna have negative 2/3 1 over x plus 2 to the 1/3. Okay, positive. So negative 2/3 x plus 2 to the 1/3 positive is mean that you will have x more than negative 2. Okay, so you see that if you have, sorry, it's going to be x less than negative 2. and you have negative 2/3 less than 0, okay, you have x greater than negative 2 by just solving the inequality. So you just multiply negative 1 to both sides and you just raise to the third power. So you're gonna just obtain this solution. So in this case, you see that at x equal to negative 2, okay, so at x equal to negative 2, f prime does not exist. Okay, so f prime negative 2 is undefined. Okay, so f prime negative 2 is undefined. So you see that if you sketch the curve, okay, so if you sketch the curve like this and you have negative 2 in the middle, so you would get psi of f prime, okay, and you're gonna have when x less than negative 2 is gonna be positive psi, and when x more than negative 2 is gonna be negative psi, and this one f prime is undefined. At negative 2, okay, so what is this function tell us? The function tells us that sometimes the function is undefined and it can be used to separate the sign of f prime for increasing and decreasing as well. So in this case, it's going to be increasing on this interval. So this one will give you increasing in this interval and decreasing in this interval instead. Okay, so this is what you get. Okay, so you see that we have the function that undefined at negative 2. We have the function that had derivative 0 at 0 here. So this guy can be used to be the boundary where you have positive side of derivative or negative side of derivative. So this guy will be called critical number also. So this guy will be critical number. Okay, so we have critical number. Okay, so what is a critical number? So a critical number turned out to be the point C where you have a prime C equal to 0 or a prime C does not exist. This one used to be the boundary where the sign of the derivative of the function may change from positive to negative. However, you may have to test the sign, okay, like solving inequality. Okay. Another thing that we're gonna have is gonna be, we're gonna talk about the local maximum and the local minimum. For the local maximum and the local minimum, you see that if you have this graph, you see that the graph is increasing until x1. Okay, so it's going to be increasing until x1 and it's going to change to be decreasing. Okay, and it's gonna again increasing from x2 to infinity. So this guy will be increasing from x2 to infinity. So you see that you're gonna have a peak at x1 and you're gonna have a peak at x2. So this one will be your peak. Okay, so this one will be your peak at x2. Okay, and this one will be the one that changing from we're gonna have to study the changing. However, the changing, we're gonna have to have direction first, and the direction that we will use will be, you're gonna use from left to right changing. So it's gonna be from x equal to negative infinity up to x equal to positive infinity. It's gonna be just left to right normally. And you see that this one is increasing. So you see the sign here is positive, and here in this yellow interval turn out to be negative, and it's going to be positive here. So this one, you have the sign of f prime, okay, sign of f prime changing. And if you draw a small arrow here, so it's going to be positive, negative, and positive. Okay, so you see that it's going to turn out to be maximum. Okay, so it's going to be maximum when positive change to negative. And here it's going to be minimum when you have negative change to positive. Okay, so it's going to be negative change to positive. Okay, so this one will give you local maximum at x equal to x1 and local minimum as x equal to x2. The thing that you have the prefix local. Okay, why do you just say local? Okay, why you just say local in this case? Because you see that this guy is not minimum. Okay, so this point is not minimum because you have something lower. So this guy is lower. Okay, so it's not minimum for global. So this one is lower. So this one is not global, or it's not going to be the whole thing for minimum. So this one will be just local minimum. What does it mean to be local minimum or local maximum? It means that you are comparing only in this room. So if you have like a 50 student and this guy has the highest score, he is local maximum, right? And if you like to compare to the whole faculty, like we have about 1,000 students in this faculty of science, you have the highest score for calculus, that guy will be the global maximum. However, if you compare only the student in this room, it's turned out to be him to be local maximum. Okay, so that what is mean to be local maximum, it's gonna be peak locally, and it's gonna be peak at this point x1, and you see that it's gonna be peak, it's gonna be a peak locally. Okay, so it's gonna be here at the green one only. Okay, and here it's gonna be the peak in the green peak here. Okay, so that is gonna be local maximum and local minimum. The thing that we shall use for testing local max and local min will be, we're gonna check for the sign. If the sign of a prime change from positive to negative at x equal to c, okay, at x equal to c, you're gonna be able to conclude that it's gonna be local max. Okay, so the picture that I will draw it for you is gonna be this one. So you just draw an arrow. Okay, so you see pretty clear that it's gonna be local maximum. And if you have the sign change from positive negative to positive, it's gonna be local minimum. Okay, so in this case, it's gonna be this guy to this guy. Okay, so that will be local maximum and local minimum. Okay, so We like to find all critical number and determine local maximum and local minimum if any of the following function. Okay, so we like to find all critical numbers and determine local maximum, local minimum if any of the following function. So you have f prime x. Okay, so first we like to find critical number. This guy come from f prime equal to 0 or undefined. Okay, ah, so in this case you're gonna first find derivative of the function. So let me write this one. Let me enlarge this. So you have f prime x equal to 0. So what is f prime? Is going to be 12x cubed minus 12x squared. Okay, this guy equal to 0. So you get x squared x minus 1 equal to 0. So you get x equal to 0, 1, critical number. Okay, so we have two critical numbers in this case, and you get uh, 0, 1 to be your boundary. Okay, so you have 0, you have 1. Okay, so you have x equal to 0, x equal to 1, and we need to check for psi of f prime. So you just check for psi of f prime. So you just pick one point. Okay, so you just pick one point here in this interval. So you just pick x equal to 2 from this interval. So you pick x equal to 1/2 in this interval, and you just pick x equal to -1 from the third interval. Why do we pick this number? We're gonna test for the psi. Okay, so when you pick x equal to 2 to plug into the derivative of the function, we're gonna plug it here. Okay, so we're gonna plug it in the original one. Okay, so we're gonna plug it here. So in this case, when you have x equal to 2, so you get what? So you get 12 times 8 minus 12 times 4. So the side will be positive side. Okay, side for f prime. And when you have x equal to 1/2, so it's gonna be 12 over 8 minus 12 over 4. So the side will be negative side. And you pick x equal to -1. Okay, so you get the negative side. So you see that you have negative side for f prime in this interval, and negative side for f prime in this interval, and negative side for this prime, for f prime in this interval. So you're gonna say that this guy is gonna be decreasing, decreasing, and increasing. Okay, so you have decreasing, decreasing, and increasing in that case. Okay, so you're gonna have decreasing, come down, decreasing, come down, and increasing, come up. So you're gonna get x equal to this guy, x equal to 1 and x equal to 0. They are critical number. And this one turned out to be local minimum. Okay, so x equal to 1 turned out to be local minimum. Why do I know that it's turned out to be local minimum? You see the shape is going to be going down and going up. So it's going to be minimum for sure. So in this case, you're going to conclude that x equal to 1 is a local minimum. Okay, that's all basically. The next one, okay, you're gonna have fx equal to x e to the negative x. So in this case, you first find derivative f prime x. So it's going to be the first derivative of the second plus the second derivative of the first. Okay, and this one will be x minus 1. So it's going to be negative x plus 1, sorry, e to the negative x. Okay, and you have this guy equal to 0, and e to the negative x is never 0. So in this case, you're gonna just have x equal to 1 for critical number. Is a critical number. Okay, so you have x equal to 1 is a critical number. And you're gonna test for the sign as we did before. So you're gonna just draw a line. Okay, so you have 1 in the middle like this, and you're gonna write down psi of f prime, and you're gonna pick one number in this interval. So you're gonna pick x equal to 2, and here you're gonna pick x equal to 0 to plug them into this derivative. Okay, so you're gonna plug in x equal to 2, so you're gonna get I would say negative sign, right? So it's gonna be negative sign, and you're gonna have positive sign in this case. Okay, so in this case, this is what you get, and you're gonna conclude increasing, decreasing here, and you see that this guy will be increasing to decreasing. So at x equal to 1 turn out to be maximum. Okay, so you have x equal to 1 is a local maximum. Okay, so this is the all thing that you need to find. Okay, you need to find critical number, and you like to conclude about local maximum. For the next one, you have fx equal to x squared minus absolute x plus 1. Okay, so for this one, it's kind of hard because you see that you need to take care absolute value. Okay, so we need to take care the absolute value here. So in this case, let me write this one into two cases as we have seen before. So you're gonna have to take care the absolute value guy here. Okay, so in this case, you're gonna have x squared minus x plus 1 if x positive or 0. Okay, and you have x squared minus x plus 1 if x negative. So this one is your x, this one is your negative x. Okay, so you see that we have the function that has two cases. Okay, so you're gonna be able to find derivative of this function. So you basically differentiate this guy. So you differentiate this guy, you get 2x minus 1 if x positive, and it's gonna be 2x plus 1 if x negative. Okay. However, for x equal to 0, we need to find f prime 0 by limit definition. Okay, so by the limit definition. Okay, so by the limit definition. Why? Because the function separate at x equal to 0. Let's first, what is f0? F0 turned out to be the first case, so it's going to be F0 equal to 1. Okay, so F0 you get 1. And you want to find F prime 0. Okay, so F prime 0 turned out to be limit. Okay, so it turned out to be limit x go to 0 of fx minus f0 over x minus 0. So you have limit x go to 0, and you have two cases. Let me write down in this way, so you get the yellow case and the pink case. Okay, so you have the yellow one and the pink one accordingly. Okay, so like I have before, and minus 1 over x. Okay, so this one we need to use left right limit. Okay, so you have limit x go to 0 from the yellow guy is the right guy. So you use the yellow guy first, so it's going to be x squared minus x plus 1 minus 1 over x. Okay, so this one is the yellow guy, and in this case you have limit x go to 0 from the right side, okay, of x squared minus x over x. So this one will be x minus 1, and sorry, it's gonna be x minus 1, and the limit turned out to be negative 1. On the other side, you have x go to 0 from the left of x squared plus x, okay, uh, plus 1 minus 1 over x. So in this case, you get limit x go to 0 from the left of x squared plus x over x. So it's going to be x plus 1. So it's going to be 1 in this case. Okay, so you see that these two guys are not the same. So we have f prime 0 will be not, it's gonna be turned out to be will won't exist. So in this case, so it's gonna be does not exist. Okay, so we have the derivative does not exist. So you get 0 is a critical number. Don't forget that we can have the derivative does not exist for the critical numbers. Okay. The next thing that we're gonna do is gonna be we're gonna go back to this guy. So we're gonna find the point where derivative equal to 0. Okay. So we're gonna find the point where derivative equal to 0. So you solve for x where you have 2x minus 1 equal to 0 and 2x plus 1 equal to 0. So in this case, you get x equal to negative 1/2. And in this case, in the above case, you get x equal to 1/2. Okay, so you're gonna conclude that x equal to 1/2 and negative 1/2 are critical number. Okay, so you have these two guys are critical numbers. Yeah. So we're gonna gather all information together. So you see that you have three critical number: 0, 1/2, and negative 1/2. So in this case, we're gonna draw a real number line. So we're gonna draw a real number line, and you're gonna plug in 3 points: 0, negative 1/2, and 1/2. Okay, and you're gonna put sign of f prime. Okay, so you're gonna put sign of f prime. So in this case, you're gonna pick one number. Okay, so let me pick x equal to 1, pick x equal to 0.25. Okay, and here you're gonna pick x equal to negative 0.25. Okay, so pick x equal to negative 0.25, and in the last interval we're gonna pick x equal to negative 1. Okay, so in this case you're gonna plug in x equal to 1. So you need to know where you're gonna plug in. So you're gonna plug everything in to derivative of the function. So you're gonna have to plug in that. So in this case, you're gonna have what? X equal to 1. So you're gonna plug into this formula, and you're gonna get positive sign. Okay, you get positive sign, and you plug in x equal to 0.5, you get negative, and you plug in x equal to negative 0.5, you plug in down here. So you would get positive and negative for the x equal to negative 1. Okay, so in this case you're gonna have you have the conclusion that you have decreasing, increasing, decreasing, increasing. Okay, and you have decreasing, increasing, decreasing, increasing. So for this one you have minimum, maximum, and minimum. Okay, so you have x equal to 0 is a local maximum, and you have x equal to negative 1/2 and x equal to 1/2 are local minimum. Of the function f. Okay, so that's all. So this one, the difficulty for this one will be the function that you see that you have absolute value. And when you have absolute value, in order to find derivative at 0, you may have to use the definition. Okay, so this one kind of difficult around here. However, if you be able to find derivative, it's turned out to need this derivative also because 0 turned out to be a critical number in this function. Okay. The next one, the question asks you to find a and b such that a local maximum value of the function fx equal to x cubed plus ax squared plus bx is equal to 2 at x equal to -1. So this thing give you that it's gonna be local maximum. Okay, so local maximum, and the thing that I will highlight will be value. Okay, so value is equal to 2. Okay, value is equal to 2 at x equal to -1. So the implication that we have here is going to be you have f -1 equal to 2 for value. Okay, so this is what we can have for the value thing. However, the local maximum, okay, so the local maximum will give you the derivative. So this one will be f prime -1 turned out to be 0. Okay, it's going to be critical number. Critical number. Okay, so you have f prime x equal to 3x squared plus 2ax plus b equal to 0. Okay, so you have f prime x equal to 2ax plus b equal to 0. And you have f1 equal to 2. So you would get, not f1, f -1, okay, equal to 2. This one is not correct. So you have f prime x is equal to 3x squared plus 2ax plus b. So we have f prime -1 equal to 0. So this guy will be 3 times -1 squared 2a -1 plus b. Okay, and you have f -1 equal to 2. Okay, so this guy turned out to be -1 cube plus a -1 square plus b times -1. Okay, so this will give you one equation. So it's gonna be 3 plus, not plus, minus 2a plus b. Okay, and you have what? This guy is gonna be -1 plus a minus b. Okay, so you get the yellow equation, and you also get the pink equation. Okay, so you have 2a minus b equal to 3 from the pink equation, and you have a minus b equal to 3 from this equation. Okay, so this is what we have. Okay, so everything is correct. Okay, so you get the first equation and the second equation. So you have these two guys. So you have equation 1 subtract equation 2. So it's gonna be a equal to 0. A equal to 0, you plug back here. So you get b equal to -3. Okay, so we have this one for final answer. Okay, so we have these two guys for final answer. A equal to 0 and b equal to -3 will give you the desired result. Okay, so I'm gonna stop here. The next time we're gonna talk about the extreme value, and we're gonna talk about the optimization.